So when we start talking about how the process of developing a C# application works, here's kind of an overview. So the first thing that we do is we develop our code. And these three files, let's just say, for example, they represent three different classes that we develop. Then we take those files and we can compile them against CSC, which is C# compiler, and that comes along with the .NET framework.
Isn't that cool?
That is cool. And that file.cs would be the code file that contains our main method, which we'll talk about more later. And Brian, this does not produce native machine code. What does it produce?
The bytecode.
It does, or intermediate language, or common intermediate language.
Yep.
Now, this common intermediate language is packaged into what's called the .NET assembly, which we'll talk more about later. And the .NET assembly is executed in the form of an exe, which is then passed to the .NET framework, common language runtime, and then just-in-time compiled to binary, where at that point, it will then execute on your machine.
So that's might look like a lot of steps, but it's really not too bad. I mean, once you get it in the form of the executable, which is really sort of a quasi-executable, it just kind of happens to have an exe.
Mm-hmm.
That executable can't, if you don't have the .NET framework runtime installed, that executable won't be able to run.
Nope, not at all.
And so that executable is really something that calls the .NET framework and then provides your intermediate code.
Right. It's almost comparable to those of you guys that work in Unix and Linux to the shebang. You know, like at the top of a script, you can say run with this compiler, but you can still set it as executable and run it as if it's an executable, but it actually executes by proxy. Something else runs that allows it to run, and this is sort of the same thing.
And it's just one of the other advantages of them also having their hands in the operating system it runs on.
Yeah, absolutely. So, Brian, let's talk about some of the goods and the bads.
Right. The good, bad, the ugly.
Yeah, so the goods. Brian, what do we got here?
There's a good amount of goods. If you come from the C lineage, whether you come from Java or you come from C++ or any of the other offshoots, it's a very easy, natural transition into C#.
Mm-hmm.
I would almost argue that if you know C++ or if you know Java, you could almost come in cold.
Yep.
Open up a C# IDE and just go to town.
Yep. Or even pick up a project that's halfway done and just keep moving. Yep.
And you just read it and just add on to it and just keep on moving. Right, exactly. And the things that are different, the IDE and Visual Studio will basically just kind of like channel you into what you're supposed to do properly. You know, not that I'd recommend that, but that's one of the things that is really good about it. Is it's very natural to understand, and part of the reason it's so natural to understand coming from those or not coming from those, even if it's your first language, is the namespace and the objects and structures are very intuitive. You know, one of the huge problems that Apple has with Objective-C is that from one object to another, you can really tell that it was written by different groups of people at different time periods. Yeah, because the way that they approach naming things, the way they approach having you interact with the object, how it's instantiated, where it's instantiated, it just changes all over the place. It's very inconsistent. You know, we always say it's consistently inconsistent.
Yeah, absolutely.
But in C#, the object structures, the namespace, especially the ones that you find in the .NET framework, not only are they very intuitive, very easy to understand, but they're really consistently implemented.
Yep.
I mean, very consistently implemented. So whatever kind of object you need, once you get familiar with the object structure and the namespaces, you're just cruising. You know, there's not a whole lot of thought and a lot of obstacle in your way.
You make a great point, because like when you are doing some super in-depth Apple development, a lot of times you have to relearn every object that you're using, but in C#, it's like, well, this other object I used worked like this. Oh, this works exactly the same way. Cool. So like when you do anything with like ODBC, whether it's Microsoft or like MySQL or SQLite, it's all implemented the same way.
Yep, doesn't make a difference, right? Which is really nice.
Very nice.
The other thing is that the language specifications allow compilers to run on any system. So the language in itself is platform independent. So it has that room for growth and that room for expansion into other operating systems and platforms, which is nice. Also, the architecture and differences are sort of taken care of by the fact that you have that compiled intermediate language. So when you do have, just like some of the advantages of Java or some of the proposed advantages of Java, maybe not the real advantages in reality, but you know, by having that intermediate language, if the architecture changes, you just have to update the runtime and you're kind of golden. You don't have to recompile your application.
Right, and you could also do stuff like run 32-bit apps on 64-bit chips, that kind of stuff.
Yep.